Hello everyone. So, in this next problem, it gives us the graph of f of x. And it asks us to find the graph of y equals 2 times f of x minus 1 plus 3. So how can we find that out? Now I want you to kind of ignore the first parts real quick because it is telling you what to do, but I want to show the logic of why they're saying to do this process. So the big function we need is 2 times f of x minus 1 plus 3. Y equals. Okay? Well, that's very complicated. There's a lot to look at. So how do I know what to do? How do I know what to do first? Well, I know that when there's this plus 3 on the end of the function, that means I'm just shifting it up 3 spaces on the y-axis. That's what we covered last time. So if I can find a simpler version of this function, like how about 2 times f of x minus 1, then I can easily work my way back up to add 3 to the y values. But even this, 2 times f of x minus 1, there's still a lot of stuff going on. So how do I know to find that function? Well, I know that the 2 in the front, when you multiply by 2, what you're doing is just expanding it vertically by double, since the 2 is being multiplied to the whole function, f of x minus 1. So if I could just figure out what f of x minus 1 is, I can easily go back to 2 times f of x minus 1 to figure out what that is, and then I can figure out what the entire function 2 times f of x minus 1 plus 3 is. So let's start out with that. Let's start out by finding f of x minus 1, which is what part A is asking us. So f of x minus 1, since the x minus 1, the x value is being subtracted with 1, what we would like to do is go shift it to the right 1 space. Remember, it's a little weird because we think of the right on the x-axis as the positive direction, but it kind of works the opposite with your x values, so we're going to shift to the right 1 space when we have to subtract a 1. So for instance, this point here is shifting over 1 space. Shift everything over, or each of the endpoints 1 space over on the x-axis. And now we can fill out our function. So we're going to connect these 2 points like such, and we will connect these 2. And now we have the function we started out with just shifted over to the right 1 space. So now what we can do is we took care of part A. Now let's find 2 times f of x minus 1. Which means, like for instance, the circular, the hollow point right here, right? That's -1, comma 2. Well, since we are multiplying the function's value by 2, this is going to transform into the point -1 still, but 4, positive 4. Because we want to double that y distance. And what this amounts to is just look at your y coordinate on the blue part, because remember we're shifting 1 step at a time. On the blue part, we want to double that y value. Well, this y value is at -1, so we shift it to -2. This y value is also -1, so we shift that to -2. And then this value is at 1, 2, 3, so it's going to go up to 6. 3, 4, 5, 6. Leaving alone the x value. Oh, and I made a nice mistake. We need to circle that point here. So let's connect our lines. Connect that with that, and connect these 2 points. And now our graph is looking a little bit different. It looks twice as big. So we should be on the right track. Now, for the last step, all we have to do, and I'm going to do this part in red, all we have to do now is add 3 to your y value, since this plus 3 is on the outside. So let's take the pink graph and add 3 to the y values. So go up 3 on the y-axis. 1, 2, 3. 1, 2, and whatever, 3. Well, I made the same mistake. It's got to be a open circle. 1, 2, 3 over here, and 1, 2, 3. Now let's connect all the points appropriately so we get our nice function in red. So that function I just put in red, I'll get rid of all the other ones so we can see clearly, is our final answer. And it looks just about right. It looks twice as big as the other lines. It looks like it has been shifted over 1 to the right and has been shifted up 3 spaces. That is a job well done.